All right, this is going to be Arduino's inputs for the Science Olympiad. The last recording, the audio did not come through, so this recording, the audio does work. We're going to talk about analog read, serial print, digital read, as well as pull up and pull down resistors. Analog read. A photocell, also known as a light-dependent resistor, LDR, photoresistor 2 is I was taught the name of it. Its resistance decreases as the light source increases. So there's an inverse relationship between resistance and light source. Let's look at the hardware assembly. Photoresistor's got a little bit of a copper wire right up on this line here. You'll see it right there. We have a 330K, and then this black is a 10K. Important not to get those backwards. All right, I'm going to show you the screen. You're going to pause this and put this together. If you do not have a breadboard or an Arduino and a breadboard electronics, think of using circuit 123D circuit by Autodesk. It's free. It'll allow you to simulate this. All right. Okay, you've put it together. I want to point this out to you. This is a pull-down resistor over to the side. We'll come back to that in the future. But notice we have our light LDR, our photoresistor up here, and we have an LED down here. Okay, now let's talk about programming this. Whenever we set this up, we always have to have those two functions. Two functions always being void setup, void loop. We also have pin mode. We have pin mode A0 input, and then we have, so that's setting A0 right here, and that's coming back off this photoresistor as an input, and it's an analog as opposed to digital. It gives you a range of values off that light LDR, that photoresistor, as opposed to one or zero on a digital. Then you have void loop, and it says, hey, define a variable called LDR, that's what IT LDR equals, and assign whatever you're getting off the analog read off of A0, that's pin mode A0. Now we're going to get, hey, off that pin A0, take that value and assign it to LDR. If we did this, we'd run the program, it'd run, nothing would seem to happen. It is getting the information from the photoresistor, but it is not reporting it. And that's why we use serial print. This allows the user to view the data the Arduino is processing. It's an incredibly useful tool. It allows you to look inside the Arduino. It is very helpful for troubleshooting, because you're going to find troubleshooting. If there's a syntax error, you'll catch that when you go to compile a code. But when the code runs, everything's running, but you're still not getting the answer you would expect or the performance you would expect, this can help you troubleshoot it. Remember, once you begin to understand what you're doing, you should be predicting what should happen and then be looking for an uh-oh moment. It's not quite, or that's a funny moment, and try to figure out why it's not working the way you expected. Now, we're going to use serial.print command. The name of the variable, in this case, would be LDR. Print out the values horizontally. It's a little bit hard to read. And then we're going to do serial.print ln is in line. This acts like a page data line break, like a return key, and it allows you to read it vertically. So, first thing in our setup, we have to add serial begin. Notice serial starts with capital S, little tip there. Begin 9600 semicolon, and then you have void loop, and we come down here and it says serial print ln LDR. So it's going to take this value. We're going to set the serial monitor up, and then we're going to print this value, LDR, right here. And go ahead and compile it, and then you're going to click on this little, right here, serial monitor. If you go under tools, you'll see serial monitor. So there's our code. You print that, and then what should happen, you should start seeing on the serial numbers spinning by fast. Let me go forward here a little bit and show you what that's going to look a little bit like. Right here is what I was looking for. There won't be any button because we haven't set up the button yet, but there would be these LDR. You would start to see, there's no LDR yet. We're going to get it so it says that, but you just start to see a certain range of values rolling down the serial monitor, and this is on a Windows machine, so it says COM4. On a Mac, it's going to be something with USB. Let's go back. We're getting a little ahead of ourselves here. All right. Now, what would be useful is as the numbers go down, we need to slow it down. And anytime you need to slow things down, that screams which command? If you said delay, you're on it. So under serial print, put delay 1/4 of a second. It normally slows us down. Now, using that print line and a delay, remember, it's slowing your Arduino down. Sometimes sampling, that's real important to be accurate. This will slow it down. Just kind of keep that in the back of your mind for future projects you ever do. All right. So we've got it now to go 1/4 of a second before it reports it. Is it slowing down? Is it coming down? Everybody's numbers will be different. Why is that? Well, it's the difference in ambient light. Everybody has different lights before they're going to it. All right. Now, to make that so it's a little more readable, we can add some formatting. So up here, your void setup's all the same, void loop. Now we're going to add serial.print, parentheses, quotation. That means literally LDR space equals space, quotations, parentheses, semicolon. Notice there's no line there. And then serial print, and there is a line there, LDR, semicolon. And what that's going to do is now print, and I want you to try it here, take a moment and pause it, but it will print, and you should get LDR equals space the value of LDR. Because in this case, it's not skipping a line, so this will print right after it's on the same horizontal line. But because that line in, it's going to go on to the next one. All right? Make sure you type it and try it out. Just reminding you again, remember every time the code sees a print line, it's like hitting the enter key on your keyboard. It's going to delay if you're doing any kind of processing. All right, we talked about analog read and write there. Let's talk about digital read. So what I want you to do is leave what you had before up. Leave what you had up before, but now we're going to add something here. And I'm going to go ahead, show what that should have been. That really needs to look like this. All right. So go ahead, please go ahead and put that in there. This is the same code. I've changed the code lines, but go ahead and do that if you would, please. So what's the difference between analog and digital? We start thinking about digital parts. And what kind of data will be coming from pin 8 that we just set up here? Here's another drawing. The lines are back to color. I just want to make sure you have this 10K resistor right here is going to the ground. This line's hot on this pin. It's going to the ground up here. All right, so let's talk about states. When we think of digital, we almost always think of on and off. Now, and that makes sense. You've got a difference potential there, and you've either got 3 on our Arduinos, 3 to 5 volts, and the off state we think of 0. And what we're really saying, we're saying V plus for those 3 volts, and we're talking ground as being the off state. But there's really another state. There's a state when the pin isn't hooked up to anything, it's just sitting out there, and it's called the disconnect. And it can range now. All right, we call this floating. Now this disconnect, say we can actually use it to seed a random number. Microcontroller pins generally can have a high impedance. Think an internal resistor. High impedance means it takes very little current to change the state. Good for reading sensors, bad because of floating. Because if it just takes any kind of static electricity in the air, anything in the air, you're going to get different values. So either we want to make sure it's either 1 or 0, 5 volts or high, 5 volts or 0 volts, or 3.3 volts or 0 volts. We don't want something in between the two, that kind of floating. So let's talk about a basic pull-up resistor. We can look at a pull-up resistor. Notice V and the voltage in, that's where the resistor is, right next to that. So just to give you an idea when it's a pull-up resistor. In this case, it's 10K. Logic gate, this is basically A0. This refers to going back into your Arduino. Here's our switch, and here's our ground. So just think this line is going into your Arduino. This is going to your VN on your value, usually coming out of your breadboard. Then you have a switch, and then you have a ground. So when the switch is open, not pressed, AO will read 5 volts, which seems counterintuitive, doesn't it? Switch not open, but now I'm getting 5 volts. When the switch is closed, pressed, AO will read 0 volts. Whoa, wait a minute. You press the switch, now it's 0 volts. Yes, because then it's going right to ground. It's going to ground. So we have that pull up, and that's why we put this 10K resistor in here, because it's going to go to ground. We don't want it just to go straight in without going through a resistor. We don't ever want it to go from 5 to ground. That's almost always a short. Okay? So in this case, the pull-up resistor, it's 10K resistor. It's not a special resistor. We just refer to it as a pull-up resistor. And so it's easy to hook up, but the logic is a little bit strange. You've got to remember your sensor pin is going to read on a pull-up resistor. In this case, the way this is set up, your pin's going to read when the switch is open, 5 volts. When the switch is closed, 0, because it's grounding out there. All right, it's grounding. It's not out. It's going to the ground, but through a 10K resistor. Let me be clear on that. Now to pull down, notice the switch is up by the voltage in, the pulled up resistors by the ground. This one makes a little more sense where the switch is open, not pressed. You'll get the A0 will read 0 volts. If the switch is closed, pressed, A0 will read 5 volts. So that's kind of, you think you hit the 5 volts, you're going to get the 1 point. The 10K resistor, again, helps with the float, so it's going to go right to there. It also prevents, if you didn't have it, if you had the VN and no resistor here and no resistor to the ground, you'd hit this, it would go straight into the ground. We'd have another short. So in both cases, it's helping to prevent shorts. Okay, and helping stop floating. All right, let's talk about coding this. All right, now, you've just named your last one. I hope when you saved your program, you gave it an appropriate, some kind of, hey, analog read program. Now, save it, and now give it a new name to save as, and you can say something like digital, analog and digital. So we're going to have pin mode 8. Hey, not surprisingly, that's digital pin, isn't it? We're going to make that an input. Serial begins 9600. And this is the same as we had before. Now we're going to add a button. This is digital read 8. We're going to assign to a variable named button. And then down here, when we print out the value, serial print LDR space quotation, serial print LDR. We've had that, right? But now we're going to put B. Notice there's no line after this serial print because we want to get this button on there. So we put this quotation, which gives you all these spaces. It doesn't erase this, but moves it farther over to the right. Button equals quotation, serial print LN button, delay 250. And so there it is. This amount of space used just keep the data more readable. Remember, this is all in the same line. And then we put, after, remember, serial button B, so it's not just reading course horizontally, we put that line after it. And so we get something that looks like this. Pretty cool, don't you think? All right. And then we can put a delay on the whole thing. And again, this is all the code at once, one last time. If you haven't done it already, pause this. Go ahead and do this. Try to do this without looking necessarily at my code right off the bat. Okay? Looking at your breadboard might seem kind of cluttered, and we use yellow for input, red for power, black for ground. Yellow for input, red for power, black for ground, and we're going to use orange for output, and that's why we're back to this. So yellow's input, whoops. Orange is output. That's why going to this LED, it's in a yellow line. Orange, and these are your inputs here and here. Now what we're going to do, we're going to add, now resave your programs. Hopefully save it as analog digital. Now do analog digital control an LED. And in this case, we're going to declare the LED variable. And we're going to make pin 9 an output pin. So we kept A0 as our analog right off the bat. Pin mode 8 was what kind of input? Hope you said digital. And then we're going to make LED as an output. We can't fit it all on the screen, so we'll show you that. Then we're going to say something. If LDR is less than 200, bracket, display right LED high. So if it's less than 200, make the LED high. Else, delay right LED low. So if the LDR is reading less than 200, turn it on. Otherwise, turn it off. All right? Because if you think about it, that means there's no light that's popping on. All right? And if we didn't have that else statement, what do you think would happen? Well, give you another moment. If you thought about it, hopefully you've come up with this answer. If you don't have that else statement, once you turn it on, it's always going to remain on. Now, let's look at buttons. Let's try just pressing a button down. If button equals 1. What is that? 1? Because we've been saying if, say, integer LDR equals analog read A0, we read from right to left. Analog 0 is LDR. So we assign it with the equal, with 1 equal. With 2 equals, we're saying, is it equal, like when we think of equal? Is the value of button 1, 1? If it is, write the light high. Else, write it low. Press the button you want the light on. Okay? So, with that in mind, and is ampersand, ampersand, and then or is the vertical marks, okay? And that allows us to do things like this. If for those people used to Scratch, if LDR or if score is less than 200, write high, else write it low. But you can use and or you can use or. And if you think about it, and narrows the search, or broadens the search. So if LDR is less than 200 or the button is press 1, turn the light on. That's when you do an or. But on an and statement, if the LDR is less than 200 and you press the button on, turn display LED on high, else turn off low. In the second instance, this is going to happen a lot more often, where all you need is one or the other. So if LDR is less than 200 or button is less than is not 1, then go ahead and press it. Or button is 1, excuse me. Or button is 1. Either one of those cases, if LDR is less than 200 or, that's what that vertical slash line means, button is 1, then turn it on, else turn it off. Okay? So those are some powerful features right there. We know how to loop, array, some Boolean logic. We're really cruising this. And so this is where you have, if LDR is less than 200 or button is 1, then turn it high. And go back in between the ampersand and or, and you'll see that it impacts this quite a bit. Okay, I hope you found this helpful. And this is what we're going to talk about in terms of digital and analog inputs and using a serial monitor. Remember, learn to use that serial monitor to troubleshoot.